Hi everybody, curve of best fit time. I hope you're studying, getting ready for your test tomorrow. All right, the table shows the median income of the U.S. families for the period 1970 through 2003. Let x equal 0 represent 1970, round to 2 decimal places if needed. That means this is x is equal to 0. This is 10 more than 1970. This is going to be 15 more than 1970, 20 more than 1970, 25 more, 28 more, 31 more, and then 33 more. So when I go to enter the data in, I want to go to my calculator. And I'm going to go to Stat, I'm going to go to Edit, and I'm going to enter in 0, 10, 15, 20, 25, 28, 31, 33. In my Y, for my income, I'm going to be careful across from 0, I enter in 9867, enter. 21023, enter. 27735, enter. 35353, enter. 40611, 46737, 42900, 45016. I'm going to give it a look-see and make sure that my lists are accurate. Okay. Now I got to look for a picture of the data. So I'm going to go to second stat plot. And I'm going to turn on my plot. I'm going to go to zoom. Press choice 9, which is zoom fit or zoom stat. And then I can see hard call, linear or quadratic. So I'm going to have to turn on my R correlation to get an idea of what my rating is. So I'm going to go to second catalog, and I'm going to arrow down till I reach diagnostic on. Press enter to pick it. It didn't like my old mess. So let's try again. Second catalog, down to diagnostic on. Enter to choose it, enter to run it. Then I'm going to go to stat and calc, and I'm going to run a quadratic regression first. And I have an older model calculator, so if I just hit enter, the screen changes. And my R correlation for my quadratic is 97, pretty good. But I'm curious about the linear, so I'll go to Stat, Calc, and choose choice 4 and run that. That one's a 98. So because my R correlation is higher for my linear, I'm going to say that it is a linear model. When I find the equation for that line of best fit, I can look here. There's my A and there's my B. So I know I have 1129.5x plus 10782.87 is equal to Y. Now, if I want to predict the median income here, I'm going to need to know my table of values. 2015 is an X value that is 45 higher than 2070. So I'm going to ask VARs to put this equation into my Y is equal to screen. So I'm going to go Stat, back to Calc, on to 4, choose VARs, Y VARs. He's a fun guy. And he goes ahead and puts those values into the calculator for me. I know that because there they are. When I hit graph, I can see the line that matches, but what I really care about is my table. And I want to know the output for when the input is 45 And that looks like $61,610. All right, a soccer ball is kicked into the air. Use X for time in seconds, use Y for the height of the ball. So I'm going to go to Stat and go to my lists. I'm going to clear this list out. Keep in mind you want to clear, not delete your lists. All right, so my time in seconds is 0, 1, 3, 6, 9, 13, 17. And opposite of 0, I have 0. Opposite of 1, I have 3. Then I have 6, 11, 11, 9.5, and 5. Then I'm going to go to stat plot. Well, my plot's already on from before, so zoom 9. It's clearly quadratic. So I'll go to stat, calc, and I'll go quadratic, and I'll ask vars, yvars, he's a fun guy, to put the equation into y is equal to for me. And there's a nice picture of my graph. So it says, use regression to find a model for the data round to the nearest hundredth. So we'll go back to my home screen, and there it is. I have y is equal to negative 0.122x squared, remember it's quadratic, plus 2.32x plus 0.423. All right, so now I have this quadratic. In order for me to answer these questions, I might need to change my windows. So I might need to make my x's a little longer. I might need to make my y's a little bigger. When I graph, I need to be able to see the beginning, middle, and end of my parabola. How long did it take the ball to reach its maximum height? I'm looking for the x coordinate of my vertex. Second calc. I need to go to my maximum, my left bound. I'm going to lose my blinky there, move my blinky there, and the x coordinate of my vertex is going to be 9.53 seconds. What is the maximum height? Is going to be the y coordinate of my vertex, and my maximum height is going to be 11.50 feet. All right, next up, the table below shows the temperature in Fahrenheit. It was used to record temperature at Dulles Airport. Assuming a quadratic relationship, what would the model predict the temperature to be at 10 a.m. to the nearest tenth of a degree? All right, so I'm going to go back to stat and edit, and I'm going to clear out those lists and enter up and hit clear and enter. All right, my time is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. My temperature is going to be 70, 69.7, 69.1, 68.8, 68.4, 68, 67.8, 67.3, 66.9, 67.1, 68.2, 69.2. All right, so I want to see a picture of the data, so I'm going to go to zoom 9. Oh, it definitely looks quadratic, huh? So we'll go ahead and we'll do a regression. We'll go to stat, calc, quadratic, and we've got vars, yvars. Well, he's a fun guy to run the regression. So it wants to know at 10 a.m. to the nearest tenth of a degree. So there's my model. Ooh, look at this difference here. I don't know how accurate it's going to be. So at 10 a.m., we have every hour from 9 p.m. to 8 a.m. So this is 9 p.m., 10, 11, 12, 1, 2, 3, 4, 5, 6, 7, 8. 9 would be 12, and 10 p.m. would be 13 hours past 9. So when I go to my table of values, I want to go to 13. It will predict that it's going to be 69.79 degrees. All right, our last practice problem for this page. The table below shows the median income of U.S. households in 2010 dollars, assuming a quadratic model. What is the earliest year the median income will exceed, that means more than, $48,000? T equals 0 for 1980. All right, so this is 0, and then this makes this 5, and this is 10 years past 1980, and this is 15 years past 1980, 20, this is 25, and this is 30 years past 1980, and we want to know the median was the earliest years. Okay, let's take a look. Get this data in Stat and Edit. We want to clear out those lists. Arrow up and hit clear. So we're going to enter in our years 0, 5, 10, 15, 20, 25, and 30. Let's see, my output, 45, 526, 44, 914, 43, 709, 43, 29278, 42, 949, 43, 178, 44, 076. Looks good. Zoom 9. It's a nice quadratic. We'll go ahead and run the regression. Stat, calc, quadrag, vars, y vars. He's a fun guy. So there's my graph. It's a pretty good one, 95% accurate. And what I want to know is the earliest year the median income exceeds $48,000. So I've got two choices here. So I've got two choices here. I can look here and draw a horizontal line at $48,000. Watch what happens when I graph it. There's my quadratic. And I'm looking to see if I see my 48,000. I don't see that, so that's not on my graph. Let's go to the table. I'm looking for 48,000. And it looks like I'm left with scrolling down and seeing somewhere between 45 and 46 years past 1980. So if I know it's between 45 and 46 years past 1980, when I look at 45 years past 1980, that puts me up to 2025 to 2026, somewhere in that time. All right, make sure you study hard. Come with questions.